Okay, one more example on how to show variation in this case that allow you to have multiple constraint. That's quite hard to show that is, but let's see. So I would like to ask you to, okay, minimize or maximize the following. Maximize this function. So this is a two constraint or a two constraint. Okay. So I'd like you to maximize this function here, f of x comma y comma z is equal to x times y times z. So in other words, think about the product between three, but here I need you to satisfy the following. X plus y plus z must equal to 32, and x plus minus y, okay, plus z is equal to 0. Okay, so you subtract 1, then so what happened? Now here, if you want to set this up, so this have to be equal to 0, so this is x plus y plus z minus 32 is equal to 0. So I'm going to call this guy here is g1, and this guy here is g2. Now, to come up with your new f, capital F, you need to write this little f minus. Now you have two lambda, it's called lambda 1 g1 minus lambda 2 g2. Okay, that means your capital F must be x, y, z minus lambda 1 times x plus y plus z minus 32. Okay, this is your g1 minus lambda 2 times x minus y plus z. Okay, this is your new function. Now you not just have x, y, and z, lambda 1, lambda 2. That means you have to show the following. F sub x equal to 0, f sub y equal to 0, f sub z equal to 0, f sub lambda 1 is equal to 0, and f sub lambda 2 is equal to 0. Each one of those have to be satisfied. Now, f sub x, take derivative this with respect to x, you have y times z minus lambda 1, so the derivative of x is 1, the rest of this is 0, minus take derivative here is 1, take derivative of this is 0, so this is lambda 2. I want this equal to 0. We're going to deal with that after this. F sub y, if you take derivative of this, is x times z minus lambda 1, okay? Take derivative with respect to y here is minus, so this is plus lambda 2 is equal to 0. F sub z, this is xy minus lambda 1 plus lambda 2 minus, sorry, this is minus, so derivative of z here minus, so this is minus lambda equal to 0. Okay, f sub lambda, take derivative 1 here, that means just left with this guy, you have x minus plus y plus z minus 32 is equal to 0, and the last one is take with lambda 2, we just left with this guy. With the minus, so let's just take the minus this, don't forget the minus. X minus y plus z must equal to 0. So this is the equation. Notice that we have 5 equations and 5 unknowns, so that we have x, y, and z, lambda 1, lambda 2. So those are 5 equations, but the question is you have 5 equations, 5 unknown, you should be able to solve it, right? Okay, so let's think about this for a moment. All right, let's think. How do I solve for this guy? Now look at this guy here. I can say that I can solve for lambda 1 plus lambda 2 is equal to yz. For this guy here, if I move this one to this side, I also can say that lambda 1 plus lambda 2 is equal to xy. Well, how could this thing is equal to this equal to this? That means y times z must equal to a number, x times y must equal to a number. What can you say like x and z? For these two things here, allow you to say that x must equal to z. Okay, x must equal to z. Alright, so what else can we get from here? Now, if x equal to z, we have something that we can play about this guy, this two thing here. If x must equal to z, that means this two, we can have this equation. If x equal to z, the minus here can multiply with minus is gone. I can get rid of this minus. If x equal to z, that means it's telling me that 2x, x plus z here is the same thing. That's 2x plus y must equal to 32, right? Must equal to 32. That means the bottom here, that means x and z are the same. That means it's 2x minus y is also equal to 0. In order for this to satisfy, I mean I can add this together. I have 4x must equal to 32. Okay, that means x must equal to 8. If x equal to 8, that's also imply that z must equal to 8. But what is y? Well, y I can solve from here. Okay, that means, notice that originally that we needed x plus y plus z must equal to 32. So if this is 8 plus, okay, I'm sorry, this guy here we solve into here. We will solve it to x and y and z here are the same. We can call it 2x. X and z here is the same. We can call it 2x. And we solve this, we can x equal to 8. And if x equal to 8, then z equal to 8. If z equal to 8, we know that the sum of these three is 32. That means plus y plus 8 equal to 32. That's imply that y must equal to 16. And check if it satisfies the other condition. Remember, the other one is x minus y plus z is equal to 0. If this is 8 minus, if this is 16 plus if this is 8, it is also 0. So that means this is your final solution. If x, now remember, I don't care what lambda 1, lambda 2 are. You don't need to spend time to find out what that value is, but it means something if you do find them. But if you don't find them, we don't really care about those values. I really care about the x, y, and z. So now the answer, x equal to 8, y equal to 16, and z equal to 8 itself. So this is the a maximum value of this function here. Okay, so make sure you try this problem. This problem here is problem number 15 on the Lagrange multiplier. So make sure you try those problems, please. Okay. Try those. If you have any questions, just send me an email. I'm more than happy to answer you. Okay. On Monday will be limited for me to access the email, so please give me some time. I'll try my best to return it back to you as soon as possible.